Hi, we're going to look at functions today and specifically looking at equations and the meanings of their slope and y-intercepts. Now, before we begin, remember that if you're looking at an equation, it is normally in this form, y equals mx plus b. M, that is known as your slope. You could also look at that in terms of rate of change. And I usually tell my students to look for the word per week, per day, per mile. That's usually your slope, whatever goes with the per. And then here we have your y-intercept. That is your initial value or fee, your startup fee. That's if you didn't have to pay anything else, this is what it would be. Or if you're looking at a table or graph, that's where your x equals 0 every time. So we're going to focus on those concepts with a few example problems. Here we have the function below shows the cost to attend the fair if you ride rides, and ride rides is your R for the R variable. So it asks, what is the y-intercept and what does it mean? Well, obviously your y-intercept is, they have it in a different form, don't be tricked here. It's just in reverse. And my y-intercept is 5. Now 5 tells me that if I go to the fair and I'll get in, that is my fee to get into the fair. That's your startup cost. Then my slope is the 1.75. And since we have that with the rides, that is the cost per ride. So if he wanted to spend $19, you could actually plug in 19 into the equation and just subtract off the initial value, the initial cost of $5, and then divide by 1.75 per ride. And that would tell you how many rides you could go on with $19. Another good example here, talking about a buffet. And this is the cost for Mrs. Franklin to go to the buffet herself. And then the 2.95 with the C's, talking about her grandchildren. So that's $2.95 per grandchild. So what is your y-intercept? The y-intercept is the number, the constant without a variable, and that's 6.85. And that's the cost for the grandmother to eat at the buffet. The slope is the one in front of the variable C. That's $2.95. And that's the cost per grandchild. Again, if she paid this much, you could subtract off her cost and then divide by how many grandchildren she could pay for out of 1865 to solve that equation. Now here we have a graph. And it says the graph below shows the number of newspapers delivered and the total pay for Leona's newspaper delivery job. What does the slope of this graph represent? So first of all, if she starts at 0, she gets no pay for 0 newspapers delivered. Now, in order to find the slope, we need to find I call it a crosshair, somewhere where this line touches both the x and the y variables. And it looks like right here is a good one. So this means for every 20 newspapers delivered, she gets $5. So we can divide that, and we see that our slope is our change in our y's over our change in our x's. These are your y's, these are your x's, and that point says that for 20 we get $5. That means 4 per paper is how much Leona's going to get for her delivery. Now here's one, but it is talking about boat rentals, and we have a fee, and it's in a table. So we're trying to find out the hourly rate that she's going to pay. The hourly rate, the fixed hourly rate to pay in this table. So basically that's telling us the per hour rate, so that's a slope. For slope, it's your change in your y's over your change in your x's again. So I do these humps here to here, and it looks like I'm adding $12. And it looks like every time I'm adding $12 for every hour that I'm going up. 1 hour, one more hour, one more hour. So therefore, the hourly rate is the $12 per hour. Now, if we wanted to find out what the initial fee was, we need to go backwards and find out what she started with when x equaled 0. No hours, just the initial fee. So we could go backwards and subtract 12, and we would end up with $15. This means that you could rent a boat for $15 plus $12 for every hour that you rode the boat. One or two more if we can. Here, Colby's putting $100 into a savings account. We have it in the graph. It's going to increase over the next 10 years. Obviously, we see an increase. What does the y-intercept represent? The y-intercept is where it touches the y-axis right there. We see that that's at 100. It's in $100. And how much time has passed? That is our starting point. No time has passed, so that is how much he started with into his savings account. He deposited $100 to start the account. Let's see, I'd like to do one more with this going backwards business. Nan works as a commission sales rep. Commission means that you get a base salary and then you get additional money as you sell things. So if we look here, it says she makes a weekly salary plus a commission for each sale. They want to know what is her weekly base salary. Base salary means before she makes any sales. That means her sales would be at 0. So we're having to go backwards. Let's see here. If we were going forwards, looks like we're adding $50 per sale. So if we're going to go backwards to see how much she started with, we do the opposite. And it looks like that is $200 is what she starts with per week, plus she's getting $50 for every sale. And we would write that equation like this: y equals 50 times, I'm going to say S for sales, plus the 200 base salary. So I hope this helps you in understanding the meanings of slopes and y-intercepts in tables, graphs, and word problems.